Guys, today we'll finish off Acyl chlorides properly. Last week, I think I was still when he went there. Show you a couple of questions that are important, a few comparisons, and resonance effect. Somebody may ask me about what's the resonance effect and also the inductive effect. So I'll summarize with a question. So here you can see your acyl chloride. I just, well, you can see here, right? Now, acyl chloride has reactions. First of all, here water, okay? Hydrolysis, right? Because the carbon chlorine bond is very weak because of oxygen and chlorine being very electronegative. So water is a main reagent. Okay? And HCl as white fumes. With alcohols, you give esters and of course HCl as well. With ammonia, it will give you your amides. With amines, it will give you your secondary amides. Now, just to summarize here. Okay, here we do. Right? If I want to plot here. Okay, remember, after you see this kind of phenyl acyl chloride is very crazy. You have to look it up and find the real formula. Now, I'll just draw for you the common ones. Right. Right. The common one, CH3, C-O and Cl. Okay, summary for reactions are to water. Remember, water is very reactive, the most reactive of all. You give, of course, CH will break. Water, you want to draw H, okay? It will break, the H and the Cl will become HCl, okay? Fumes, dense fumes, okay? White fumes, but steamy fumes is a better word, okay? HCl. And one of the schemes that use steamy fumes is most acceptable. Fumes, okay? White fumes are normally for ammonium chloride, okay? Chloride is white fumes because it's really white because of the so here what happens is that you give you your, of course this part will go into your carbon group, will give you your ethanoic acid. So this is your direction in water. Now the other direction of course is with ammonia. H. Of course ammonia here, this is all this reaction, this oxygen here, this is delta negative, right? This delta positive. These are all nucleophilic substitution, all these two, right? It's the same here. So this is a nucleophile. Remember this, nucleophile. So is water a nucleophile. Remember this, okay? Right? I'm taking a carbon which is delta positive. Okay? So of course you will get your CH3. Remember this one here, text here, doesn't come from the Cl minus C, and H here. Right? So the remain here. Okay, so this is a nucleophile. So this is the amide. Plus HCl. Now this is very important. These are very important here. Because sometimes they ask you to, how will you show from an experiment this is faster than that, or faster than that. These two fellas are HCl. Okay? HCl. In water, you give H plus and Cl minus. So how, once when it's formed, how do you know it's formed? You use silver nitrate. Right? Silver nitrate. All nitrates are soluble, isn't it? right? So immediately it will give you a reaction of silver chloride, which is white PPT. So how fast compare this one here, right? This one here now, maybe I just skip. Okay. The question that was acyl chloride. So just to see how you show in exams, experiment, they ask you give an experiment to show which is faster. Okay? Explain it's okay because explain why this carbon here is very delta positive. Yeah, right? Yeah, right? Because of the O and the Cl there. Now for this kind of fin acyl chloride, let me show you the okay, 5 minutes now. We have to see questions here. Describe an experiment, experiment that you will show that acyl chloride here, or ethanol chloride, reacts with water at a much faster rate than fin acyl chloride. What is this damn thing? Right? Oh, I know benzyl chloride. Fin, right? Includes the reagents you would use. Actually, here is silver nitrate, and the observations you make from each chloride, which is the YPP of silver chloride. So actually, I went to look it up. This is a fin acyl chloride. Do you know this one? So this one here, the fin. Here, now there's a carbon that separates it from the Cl from here. So this carbon here is not right. It's not well the pool of this one is hindered. So it's only this one here. That means this one behaves just like a normal. Okay, right. Maybe a bit more pooling, but you know. So the bond here is not very weakened. It can be comparable to what? Comparable to a normal alkyl halide. Another C. Right? That means this is not very, a bit more, but not very delta positive. Right? If you compare this one here with your acyl chloride, this one here, pool here and pool here, right? This one is very big delta positive. Okay? So this is more reactive. Why? A couple of mistakes. You point. Okay, more reactive. Okay, I put it reactive. More reactive. Active. And this one. Okay. So this one, the Cl comes out, yeah, slower. Okay, Cl minus comes out slower. So therefore, the appearance, so you put silver nitrate equals, this one here give you a very fast what? Appearance of what? Appearance of silver chloride, which is right, it's a white PPT. Okay. Let's see how the answer goes for this fellow here. I think this one here. Okay. There. Right? It's 3 marks here, then they put 4 marks. I don't know why. Alright, see this one here. Okay, and see they put RCN, which is your fin acyl chloride. Okay, so silver nitrate. Okay, okay, use a pH probe as well. pH meter to see the pH. Right? This one here will be very much acidic. Very low pH is not. So white PPT appears, which is silver chloride appears, okay, faster. Right? So 1 mark. 1 mark for the reagent, 1 mark for appearance of the white PPT faster, okay. Okay, now why? Because see here, the carbonyl group is polarized, okay. Carbon is more delta positive, okay, than the RCl. This is the normal fin acyl chloride, right? So that's why it's a faster reaction. Okay, so you can see here, the delta carbon here is more polarized. It means the delta carbon here, this one here, very big. Because of polarized, why? Because of Cl and oxygen. Okay? Right? This one is way away. So here the carbon is here, the plus is smaller. Okay? The mention of electronegativity on its own is not enough. Okay? Say that what happens if when these two are high electro what? Negative. What do you do? Able to polarize carbon and cause the delta positive to be very large. You must say the effect. So here, mentioning of electronegativity is not enough. So Cambridge is very strict about this. So make sure you talk about the reason and the cause of the reason. What the reason make it to be that cause it to be more reactive. Okay? So I'm going to save this just in case you can see that. Okay? So now that is how we talk about this one here. Okay? Alright, now let's go back to our original. Okay. So here we have got with ammonia. Right? Of course, if I were to react this, okay, with amine, CH3. Okay, again, this is a nucleophile also, right? Because it's our tag where carbon. So of course, you will get a secondary amide, CH3, C double and your N and a H and a CH3. Right? Yep. So this. So it's a secondary amide. Now, of course, besides this one here can also attack an alcohol. Two alcohols are being, make sure you know, one is aliphatic alcohol. So I'm giving you the whole picture aliphatic with straight chain alcohol, which is, for example, CH3, CH2, and OH. Very simply, you can draw it out, obviously, if you have a problem, revising, draw everything. Draw and make sure you draw again and again so that you are familiar. Now, you should put the thing opposite each. Okay, this opposite the whole thing. Problem is it? Okay, and then box the HCl. Come on. So obviously, you get what? You get esters in. Okay, here ester. Okay, here and O and CH2 and CH3 plus HCl again. HCl comes up. Remember, as we did how to name ester, just to remind you, some of you will brains or cow, you know. Right? This is what? Tell me, part that belongs to your carboxylic acid. Carboxylic acid part. If you talk about carboxylic acid and alcohol, here comes from the alcohol. That's the name. This is called the naming system. So here instead comes from the acyl chloride. So, which is this part, okay? Two carbons. So it's ethan, no? 8, why 8? Because all esters come from fruits there. So what do you do with fruits? Your nose. Eat, is it? So I ate. Oh, I ate an apple. Oh, I ate a durian. Oh shit. Oh, I ate an orange. So it's ester. It's not belong to the alcohol. It's alcohol. Two carbons. So same name. Okay? Right? Now, this one is particularly important for the reaction of phenol. I told you already, phenol finds very hard to react with the benzoic acid. Remember the big fat lump here, the benzoic acid. Right? This fellow here finds very hard to react with phenol because what are solids, right? Okay, so they don't react. No reaction. Okay, so normally for it to react, this one has to become benzyl chloride. Okay, phenol. And phenol normally you don't put the OH, you put the sodium form, which means you dissolve it in alcohol. Later I'm going to talk to KIs. Yeah, talk now. Okay? See now. Right? You get LaCl. See now. Okay. Quite common. Right? And then you get your ester. Right? Ester here. Okay. And to the see now. To your phenol, baby. Right? How do you put the name? Name. Okay, so from the carboxyls from your A sub, right? 6 plus 1. So benz, phen is 5, 6, 7, is it? 6 plus 1, 7, so it's benzoate. It's 6 carboxyls, so it's phen. Phenol benzoate. This is your ester. Now here, if you use this one, the acyl chloride here, okay, with the phenol, okay, same idea, okay, okay, right, HCl comes out, okay, and then you get of course the CH3, C double bond O. And to what? To O and okay, plus your HCl. Now this of course the name. So ester again, remember this one come from your carboxyl acid here? Oh no, it's a process to carbons is ethanoate. And this C6 there, right? 6, right? So it's phenol. Okay. Right. Now sometimes they put Na plus here. Also can, the reason is more reactive. Okay, it's sodium dissolved here. So sodium, we get sodium chloride here. Okay, so I give you the big picture already. Everything is here. Right. You can see I'll try to do this. It's called spider-ram, whatever the ram is. Just do it. Okay, it sort of summarize everything. You put equations here and there, so you can understand. You put the names here and there, right? So it gives you a good overall picture. Okay, not very ideal at everything, but gives you a good understanding. See how to connect everything. So you get ester form. See ester, okay lah. Amides, secondary amides, carboxyl acids. So one, you can form carboxyl acids on products wise. Okay, one. Secondly, you can form what? Amides. Primary and secondary. Thirdly, you can form what? Esters. So these are all products. All are products. Right? So that's why your acyl chloride is very useful. You can form so many types of substances, and now I'm going to show you that it can form some more polymers. Good polymers. Whether I should go straight to that or not. Let me see. We have to finish off early. I think I did quite a lot of quite tired of all these things already. Okay, never mind. I think we do one more just on the okay, very simple. Acyl chlorides are useful intermediates. See, very useful intermediates. Very useful now. Yeah. In organic synthesis, that means you make organic substances, especially if you want to be a pharmacist or a drug addict, whatever. You want to make your own drugs, you know? Right? It's very useful, very fast, very reactive. Suggest a suitable reagent to convert carboxyls into acyl. Of course, PCl5, isn't it? Like before. The concept equation is quite simple now here. Very simple. In the boxes provided, draw the structures of the compounds from a benzoyl. Benzoyl, correct. Remember, benzoyl. OYL, remember? Do you agree? Benzoyl. See, etanoyl. Etanoyl. This is the correct name. Rather than chloride. This is your CH3. This is the correct name, no, my friends. The acyl chloride is a very old name which they so commonly use, okay? Acyl chloride. That they kept on using it. Okay? But this is the correct one. OYL. Okay? OYL. OYL is for this one. So benzoyl chloride, which is this one. Okay, so this is very active. Sangat balas, sangat cepat. Okay, we are doing the same thing, right? Remember, if you have a problem, right, draw out everything. Use a hand. I tell you, you guys are all quite good. You look at the question. What is so difficult? Let it go. Try all the things. Use all your senses. Smell it if you want to. Okay, draw these things in a box. Box a head also. Okay, okay. Okay, what? Of course. And is it? Okay, what? Of course. What? And of course, HCl. Yeah. See, easy, is it? So it's something with alcohol. Give what? Ester, isn't it? Right? So I close my eyes. Okay, right. Okay, this part here. Now, if you have a problem, draw some first. The best way is to draw the acid first. Okay, to C, double bond O, and to the O, and to the C2H5 here. Right? Okay, you want an organic substance only. Okay, you can put you scared. Scared. See how here? Okay, pass this one here. Okay, right. Name of the function group in A, of course, is ester. B is what? Amide. Okay, this is it. What direction? What direction is type 2? Okay, what direction is this? Condensation. Okay, condensation. Right? Condensation. Is that us version? Let's check. Then negative 41. Negative 41, sorry. I thought that. Negative 41. Okay. Yeah. Okay, here we are. Actually we did before, right? We did some of this before. See? Condensation. It must be nucleophilic substitution also can. Right? See here are the amide form and the carbon ester form. Yeah. So just want to show you okay. Why nucleophilic substitution? Okay, see. Right, why is nucleophilic substitution? Here. Yeah, right. Here is the delta, negative delta. So this carbon is delta. Yeah, masuk sini. So come over here. Okay, one hydrogen go over here to maintain the word from there. So it's like this now. So it's this called nucleophilic. What? Stop. Stay. Okay. Right. Now I have most of the kind of questions, okay, I went through quite a lot. Okay, so okay, let's look at the here I've got down here I copy from some narrative. Okay, see how we have finished all this already. You look at it here, right? Describe hydrolysis right here, which means reaction with water. Reactions are also with alcohols, phenols with the primary aim is also with alcohol. Yeah. The ease of hydrolysis with comparative using okay, compare the alkyl, aryl, and okay, use of it silver nitrate to show the come off faster. Okay, ester form we talked about it already. Okay, acyl, chlorides, and phenol benzoate we talked about this. Now the last part here, right? Acid and base hydrolysis of esters. Now this one we done before in light color is AS. Here, this kind of function. Okay, so this part here we'll summarize it here. Actually, this part here will be done again in polymers. It's the last chapter. The last two things about chemistry is one is amino acids, which has joined with proteins, and number two is polymerisation. So this is the last week already. So I hope to do it maybe next week. Today is Saturday, tomorrow is Sunday, rest day, man. Okay, so I'll finish it next week already. Remember, next week we will have a discussion group. All right? For those who cannot join, don't do the homework. Don't join. You're useless. Just make everybody go slow. We are not going to go slow for you. So those who have done the homework, okay, question to ask, I will organize two next week, next month, it depends on you all. I suggest Wednesday and Friday or whatever it is, but I will record it and I'll put it on YouTube. So those who have no questions, maybe learn something or not learn anything because they're not interested. You're quite dumb. You think your father will have money and you can always be a professional baker. But the rest of you who wants to live a life that is meaningful and also you can work and get a degree and then you try your own makan, you care. You don't want to study, you don't want to do well in the exams. You ask the money from your father and mother, always asking mom, dad, money, like a professional baker. That's why you are fine. No, I'm not against it. I hope it's fine with you. No pride, just go ahead and do that. Okay, now let's go to here. Okay, last part here, which see here. I put this on, I don't know where I do it. Bless the guy. I don't know. Sorry, I didn't. I just see I got cut and paste. Okay, now this one is quite interesting. Aspirin. Right? So okay, look again. This is aspirin. My dear friends, all the doctors say aspirin is very useful. It's an anesthetic drug, which means it will cut down pain. It's also able to reduce blood clotting. So your heart problem, stroke. So this is a mild one. But of course, those things aspirin will bleed. That's number one. So your father, if you take mild, heart trouble, you might bleed. Okay, so be careful. So how to make aspirin? Very simple. Now you start with this one here. This is a okay. Now it's called can either way that's it. Now it's called benzoic acid. Okay. So the mother is called benzoic acid. This is called hydroxy. So it's 1, 2. So it's 2 hydroxyl. L. Okay. Acid. So you put this fellow there, right? Okay, this one will react with the OH. Somehow, I think they did something to prevent it. You get this acid anhydride. Don't worry. We say that you only react with your phenol here. Okay, so this one H comes out. Okay. Again, what direction? You can put condensation or what? Or nucleophilic substitution. Back here. Okay. So here we'll go to here. Okay. So you get your ester. This is your ester linkage. Aspirin is an ester and a carboxylic acid. That's why it's acidic. Acidic. That's why it causes bleeding in your stomach. Okay. Just stay there and then of course you will attack the stomach wall and blah blah blah. Why overdue aspirin has a vinegary smell? Why? Okay. How you prepare? Blah blah blah. Now one year they ask why vinegary smell? Because when this is exposed to air, right? Air got what? Got water, isn't it? Hydrolysis about hot day, blah 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 will break. Hydrolysis. Hydrolysis. Guess what happens? Of course, you get the other product. You get your what? What is this? OH here. You get the original. And of course, this part here becomes your carboxylic acid. It becomes an ethanol acid on your vinegar. It's a vinegary smell. Okay? It's a vinegar. Or ethanol acid. Vinegary smell. Okay? That's why you now aspirin they put in aluminum foil, no? They put this aluminum foil, okay? So it's protected from water. Aluminum foil. Okay? Just to let you know lah. This is something kill people. Okay, now here is when you make polymers. What polyamide? Okay, here this polyamide. Form 5, I'm not going to try to teach you anymore. This form 5, okay. Polyamide. Okay, and this polyester. This is actually, who knows what's the normal name for polyamide? Because here, I hear a sound. Useless. Nylon. Polyesters. This is basically to make cloth, is it? Right? This is to make like guitar strings and fishing nets. This is to cloth and naked body, okay? Right? Polyester. So now, how are they say? See, the thing is here, guys. Whenever you make a polymer, you want to make a long chain. A long chain must have the 2 functional groups, one of dyes, is it? One here and one here. One here, so they can continue, is it? You put only one functional group cell, you don't one here, okay, only one reaction, okay? So here is like diamine and your diacyl. Now, normally in form 5, you will say that, oh, we use a dicarboxylic acid. Fine. Theoretically, it's fine. Do and why here? Theoretically, it can react, but it's very slow. Okay, very slow. So in the industry, your grandfather died as well, they haven't produced. So you people ask, hey, where's my nylon? Oh, coming soon. Won't die like loser, I tell you. So they use acyl chloride very fast. Same thing, whether for nylon or polyester, you can use. So for nylon, use the diamine, okay, and the diacyl chloride. For polyester, you get diol to alcohol here and acyl chloride. Okay, let's just let me show you some here. Okay, see here, easy, isn't it? Okay, so you just box the HCl. You put your diacyl chloride here. It's a diacyl chloride. Okay, of course, you want to continue, you can put the Cl here and the Cl here and the blah blah blah. This form 5, guys, I'm not going to go over again. You don't know what the form 5. here of course plus, and separate the hydrogen so you can see clearly. Okay, here's your C6H, sorry, CH2. This is your this is nylon 66. If you remember, I will go through later. Okay, under polymerisation. Okay, so here box again. Here box again. Here box again. Here box again. Here. So you can get a long chain, isn't it? Right? So long chain is normally we put here. The tail is important. Tail, right, to here. C double one O. Okay. Right, the H of the. Okay, CH2 4 right to C double one O. And here to add to H here. Of course, here you want to continue with H or not because it's a peptide linkage, right? Or amino linkage. Amine linkage. Amino linkage. CH2 6. It's called nylon 66. 6 carbons here, 6 and 6. It's called nylon 66. Okay, that's the reason. Okay, here of course we N and H. That's why you in here and put a okay here. The tail must be there. The tail, guys. Okay, here normally it ends here. Okay, the tail here, no, it's on here. The tail here suggests that A is going to continue. Okay, no tail, no marks, no. It's called a tail. Okay, so this is called a repeat unit. That means this two will continue to repeat itself. Repeat unit. 4, 5 bar, guys. So this is called the peptide linkage or amino linkage. Peptide linkage. Peptide because if it's a protein called peptide, peptide linkage. Amino linkage, okay? Now this is very important. I'm going to show you this one here because it will come out. See here now there are three tri-acyl group here. Okay, remember, guys, it's like this. So it's okay, and they're very useful in industry. Okay, I got the whole ring. CL1O and CL here. Here is a CL1O and CL. Here is a CL1O. CL here. Okay, all these can participate in the nucleophilic substitution or in condensation with this one here. Now this is a ring carbon H2 here. Don't be afraid. New thing doesn't mean that it's very difficult. It's just new because you are like some the country boy. Okay. Okay. So now here the hydrogen here. Again, it participates in what? It participates in what? Nucleophilic substitution. Now you want to draw it nicely. Okay, I'm going to draw it nicely here for you, right? Of how this reaction occurs. Okay, just to give you a taste. Okay, I'm going to arrange it just like this. I'm going to arrange it like this. So the way you arrange things can help you to perceive things clearly. Okay, I'm going to draw the localized concentration like that. Right, here is your carbon double bond O and your Cl. Here is your carbon double bond O and your Cl. Yeah, because here is a carbon double bond O. And this is very important, no? After you can see one. Okay, so I'm going to arrange now this. Now this is your secondary amine. It's a cyclic as well. Never mind. Don't be worried. You say, so they will teach you idiot. Use a brain. Brain. One without brain. Okay. Here you want to draw your image here. Okay. Right. So draw everything out if you got a problem. Don't sit and cry. Your mother comes and say, hello, my darling, what's wrong with you? Say, oh, I cannot draw something. Say, oh, my darling, I'm going to pamper you. Okay, draw that one here. Use your brain. You are mature. Form 6 already can get married already. Still crying, and say, how to solve? Use your brain. is Cl, isn't it? And here, okay, okay. So what happens? Condensation, substitution. See, this kind of long chain. But here, this one can also not. You know, here can I can have another one here. See, an N here. Cause cross linking. Later I'll show you. Okay, to here and here. Right. Here forms here and to another one here. So this one can join another long chain, isn't it? And that is called cross linking. The mix, it will make the polymer very hard. No? Remember like form 5, cross linking. Cross linking. How many of you remember linking? Linkage. How many remember? Rubber is very soft, is it? That's why when they took it to England, too soft. Winter is okay, hard. But summer, wow, like you know. So the wrinkle all becomes very sticky. So what they do? They make the rubber harder. They vulcanize it. That means they link all the polymers by using sulfur. Sulfur will link it so they make it harder and it won't melt. Same thing here. Structures will be harder when you link it. Okay? Right, I'm going to show you a question that talks about this. I think I put it in already because I think it's much. Okay, so I'm going to actually do a little bit just page 3, 5, 2. Okay, I do the resonance thing later. Discussion. Okay. Short. Look at here. Right? Beautiful question because it gives some terrible. Polymer G. Oh, mother help. Oh, cry, sit down and cry. Okay, don't care. Always look if the polymer. They say the polymer really what? The following diagram shows a section of not a repeat unit. Okay, they say of a polymer G that can be made from two monomers, E and F. Very simple. We do this all this later. Okay. Now, always remember. Okay, they will lead you on E and F giving this whole thing. E and F are the starting monomers. Okay, so E and F, you remember these are the monomers. Monomers are the beginning one. Monomers. This is called polymer. Poly. Many. Okay. What the polymerisation means is okay. Look for the linkage. In polymers, there's only two types of linkage for you, which is what? Ester linkage and what? Louder. What? Let me see amino. Okay. So of course, ester linkage should be C double bond O. Okay. Amide would be NH or C also can. You can put either way first. So of course here there's no N, is it? This one is your ester, is it? See ester 2 here. Let's continue. So how do you break it up? Very simple. To find the monomers, remember this is where they join. Break up the carbon over here. Okay, break up here. This one must come from your what? Carboxyl, isn't it? Or your acyl, isn't it? Come from alcohol, isn't it? Yeah, alcohol, isn't it? Break up here. So how do you find? Join break up to break up. Okay, we use the red color here. Join break up to break up. Now break up here. Alright, join here, circle to here. That is one monomer. Yes? What is monomer? The benzene ring here must be OH here. Right? And then OH here. Directly opposite now. Okay? Then break up to break up. Oh, nice. Count the carbons, you idiot. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Now, oh, come double bond here. Okay, now you can put acid chloride, or you can put carboxylic, up to you. But as I said, normally this is better. Alright, it's better. So this is your H. You better write this out if I'm writing the skeleton diagram. Okay, H. And of course, it's not here at the Cl. Now this one also can, this is okay, but you also can put the sodium thing here, which means like that, O minus. Sodium one is more reactive, because it's very easy. Plus, what is this? Okay, either way, okay, it's the marking scheme, O minus and Na plus. Either way, this one here, or you can put OH here up to you. Okay, monomers. So easy? Yes, easy, of course. Okay, now you see what conditions I need to make a polymers G from this. Now you can see in exams 1.1. Okay, I see what conditions in the lab. Okay, now this is 12 May June 42, 12 May June 42. Okay, name the type of polymerization made in the polymer, because it's not a double bond, that's called addition. It's called condensation. Okay, now here we what? Condensation. Condensation, polymerization. Alright, what are the structures? Alright, we have given the sodium version and the phenol version. We have given the diacyl or the dicarboxylic acid. Okay, yeah, guys, sodium version. They are not very good in the sense that they didn't put the plus and minus, sign. See, here should be sodium is plus, minus, okay? Either way, okay. Okay, now either way, your dicarboxylic acid or your acyl chloride. Okay, all right. You can use either reverse or decimal E and F. Doesn't matter. So how do you do it? Okay. So the thing is, make acyl chloride from F. Okay, that means if you got this one here, right? If you got this one here. Acyl chloride, acyl chloride is still the preferred one, baby. Okay. Now, make acyl chloride. It means how do you make acyl chloride? Put BCl5. Well, to make acyl chloride. If it's not already there. It means if you use benzoic acid, you must say benzoic acid is mixed BCl5 to get your acyl chloride. It's more reactive, right? Then you have to make, you have to dissolve your phenol in NaOH to form this one. See, that's what they want. Because in actually experiment you do this because this way is more reactive. The Na is more reactive. Make a solution of E in. So anyway, the key thing is always use sodium salt. And the acyl chloride is better for what? For polymerization. Very important. So you see in exams, they actually want you to know what happens in industry. Not just the head knowledge, you dumbo, you think you're very smart, right? In industry. Because why? Because it is through rate faster. Money, you want to make money, is it? 10 years we come with a product, who wants to buy from you? Can, huh? Right? So I have actually finished what I okay. So here, this part, last part here, which I told you before. One of the monomers E and F could be changed to make a more rigid. You can change the structure of the monomer to make it more rigid, shorter. If they're long out, very curly, they move here. If they're very short, they're rigid. Or you cross-link it. A similar chemical type of G suggests which of the two monomers could be a change in the structure of the monomer. Okay, now I show you E and F structure. Okay, now I will show you the marking scheme here. They say, well, see, instead of using the long chain of 7 or whatever, you decrease the chain length. Okay, see, so ignore but not longer than, okay, you shorter the length, they remove less. That means they are restricted. Okay, right? Here as well, you use a carboxylic acid. I don't know why. Now this one here is better cross-linking. Right? Tricarboxylic acid. That means you use like that here. Like this now. Okay. Or triacid. Or triacyl. One filler here. This one can go on and on. This one here can cross-link with the other long chain. Yeah. Or here, I'll tricarboxylic acid. Same thing here. One here. Okay. One here. Okay. Here is your. Sorry, I do both of them with carboxylic acid. One must be a phenol, is it? Okay, phenol. This is phenol. Okay. You do phenol here. Okay, so if it's phenol, right? It'll be O. Okay, let's go to here. So here's O. Okay, so this filler here can cross-link, while these two will continue with the straight chain. Or here, okay, Cl, let's put another one now. Okay. One of them here. Triacyl. H here also can, or whatever. So this one here can cross-link it. You don't care, as long as you know, you show your smart aleck, your smart head. Okay? So you can make it harder. Okay, right? So I finished it's right properly. There's one summary question here. A bit nice. Because okay, yeah. Okay, it's a summary or scheme diagram, which is very common these days. Compounds B and W can be synthesized from bromo, benzene, or fluorine. I'll start with only one further. Okay. Now, of course, from here, I'm going to. Of course, you want to put a CH train on to the 1, 2, 3, 4th position. Okay, bromine will have 2 and 4 here. Okay, of course, you need CH3 here. Okay, and there is Br here. And what is this one? It's alkylation. Okay. Here, let me see here. Put the amine here. Then you got this fella here. It's a chloride. So you work backwards. And try, to get acyl chloride here, of course, this one must oxidize to your carboxylic acid, isn't it? Your benzoic acid, see? So use a brake. Where's the brake? Outside out this one already. Okay, we survive it. Okay. Yeah, nitro. Very simple. Okay. Three. So 4 and 55 55, 60. Here, say, isn't here? I got a. This must be. Yep. Oh, oh, let me say this one. No. So here, give you your A minus it. So how to go from here? Yeah, very simple. Remember, not NO2 with the rate must be 10 plus concentrated what HCl hit better. See, so it's very simple. See, so you get a whole run, a whole meal of kind of reactions. Okay, I think I finished already. So review it, spend time writing down a lot. If you got a problem with memory, the only thing, one advice for you: 3 steps. Review. Do it again and again and again, 3 times. Keep on doing it until you get it. There's no quick formula. There's no quick stuff. There's no like, if I think it out, I will score. All these things must be done. Write up again, okay? And you see all these things. I didn't learn it. I'm not very smart. I'm quite stupid. I'm very clever. I'm clever to find for a way out. Okay, you must first you are all smarter than me, okay? Right? You are 21st century people, 22nd, whatever. I'm a very powerful dinosaur already. But I'm ready to learn. You? Okay. We have finished, huh? Alright, I'll see you